Do galaxies form because a bunch of baby stars were all born at the same time, or are they hideous Frankenstein monsters of galaxies past? Hey Space Surfers, Julian here for DNews. You'd think we know everything there is to know about galaxies by this point. I mean, we live in one, and when we look outside of it, we think there are at least 2 trillion more, and that's just in our slice of the universe that we can actually observe. So, there's no shortage of samples to study, and yet we still have some very basic, very unanswered questions, like how do galaxies form? There's no definitive model, but we thought we had a pretty good idea until a recent discovery has raised some eyebrows. Scientists studying a proto-galaxy 10 billion light-years away, known as the Spiderweb, noticed that the large cloud of gas had young stars popping up all across it. They were jumping to life out of the negative 200 degrees Celsius gas, which surprised the astronomers who were expecting something completely different. This discovery supports something called the top-down approach of galaxy formation, which posits that the first galaxies started from huge gas clouds that had enough internal gravity to collapse and begin star formation until the clouds fragmented and became separate galaxies. Now, what the scientists were expecting was something called the bottom-up model of galaxy formation, which is the more widely accepted model. It says stars formed in smaller clumps early after the Big Bang, and these clumps then mashed into and merged with other clumps, getting bigger and bigger until they reached galactic proportions and settled into the orderly structures like the spiral and elliptical shapes we see in more recent galaxies around us. This idea is supported by the fact that we observe a lot more small galaxies than large ones, and when we look back, we see clumpy-looking galaxies and plenty of mergers. In fact, we think that nearly all massive galaxies went through a merger at least once by the time the universe was 6 billion years old. So there's evidence that supports both models, and of course there are combinations of the two models, and some even incorporate dark matter maps to help explain why the gas clumped where it did. But these are just ideas. We need to look back even farther to actually see what's going on in newborn galaxies. Right now, the Hubble telescope's infrared instruments can look back to within hundreds of millions of years after the Big Bang, but that's not quite far enough. That's part of why the James Webb Space Telescope is such a big deal. It'll allow us to look farther into the past than we ever have before. Happily, I will leave you with a mini mystery that scientists think they've solved. The question of the roles supermassive black holes play when a galaxy is first emerging from the cosmic soup was long the chicken and egg dilemma of galaxy formation. We find these extremely dense points in space at the center of most galaxies, and it's thought that their gravity anchors the whole thing. So, do the galaxies condensing cause a black hole to form, or does the black hole come first and help pull the gas cloud together? For that pickle, it looks like it's the latter. While galaxies today appear to be proportional to the mass of their central black holes, early galaxies have disproportionately large black holes by comparison, suggesting the black hole came first. That answers that, but there are plenty more mysteries out there, and maybe one day we'll know just how our cosmic home came to be. So our galaxy has almost definitely been through a merger before, and we're gonna do it again with our galactic neighbor Andromeda. Now, to brush up on it before it gets here, check out Julia's video right here. So, are you team top-down or a bottom-up kind of guy or gal? Let us know in the comments, subscribe for more, and I'll see y'all next time on DNews.